Analysis of symmetrical frame using slope deflection method. Analyze a portal frame loaded as shown in figure by slope deflection method and draw the bending moment diagram for given figure. In this problem, ABCD frame is given. AB portion and CD portion is column and BC portion is beam. In BC portion there is UDL load 10 kN per meter acting. In AB and CD column there is no load acting. Step 1. Fixed end moment. In fixed end moment calculation, for AB and CD columns there is no load acting, therefore M of AB, M of BA, M of CD, M of DC, 4 moments are considered as 0 because there is no point load or UDL acting at both the columns. In BC beam there is UDL load 10 kN per meter acting for a 6 meter span. Therefore, for UDL condition, for a left end minus WL squared by 12 and for right end plus WL squared by 12. Therefore, substituting both the values, we will get minus 30 kN meter and plus 30 kN per kN meter for respective ends. Step 2. In this frame, there are 3 number of spans. Therefore, 3 into 2, 6 slope deflection equation will be calculated. Step 2, slope deflection equation. M of MAB. MAB is equal to M of AB plus 2EA by L into 2 theta A plus theta B plus 3 delta by L. A end is fixed, therefore theta A will be 0. B end is continuous end, therefore theta B is kept as same. Substituting other values, we will get MAB as 0.67, EI theta B as first equation. Similarly, for MBA equal to M of BA plus 2EI by L into theta A plus 2 theta B plus 3 delta by L. Substituting theta A equal to 0 and theta B as same. Delta value is not given, therefore delta value also treated as 0. Finally, we get MBA as 1.33 EI theta B as second equation. Similarly, for BC span, MBC is calculated as M of BC plus 2EI by L into 2 theta B plus 2 theta C plus 3 delta by L. Delta value is not given, therefore delta value is treated as 0. Theta B and theta C are in continuous end, therefore it is kept as same. Substituting M of BC and theta B theta C values, we will get MBC is equal to minus 30 plus 0.67 EI theta B plus 0.33 EI theta C as third equation. For right end, MCB equal to M of CB plus 2 EI by L theta B plus 2 theta C plus 3 delta by L. Similarly, substituting same values as above, we will get MCB as 30 plus 0.33 EI theta B plus 0.67 EI theta C as fourth equation. For CD column, M of CD plus 2 EI by L into theta D plus 2 theta C plus 3 delta by L. D end as fixed, therefore theta D is considered as 0. Delta value not given, therefore delta is equal to 0. Finally, we get MCD is equal to 1.33 EI theta C as fifth equation. For right end, MDC is equal to 0.67 EI theta C as sixth equation. Step 3. Equilibrium equation. Equilibrium equation occurs based on the continuous end and fixed end. In fixed end, there will be no equilibrium equation. In B and C continuous end, there will be equilibrium equation. For B end, MBA from column and MBC from beam portion. Adding both, we will get seventh equation. And similarly for C end, MCB in column beam portion and MCD in column portion. Adding both, we will get 8th equilibrium equation. Substituting above 6 slope deflection equation in 7th and 8th equation, we will get 9th and 10th equation. Solving 9th and 10th equation, we will get unknown ei theta b and ei theta c values. Ei theta b we will get 17.96 and ei theta c as minus 17.96. Substituting both the values in 6 slope deflection equation, we will get final moments value. Final moments for this problem, MAB is equal to 12.03 kilonewton meter, MBA as 23.89, MBC minus 23.89, MCB 23.89, MCD minus 23.89, MDC minus 12.03 kilonewton meter. Before drawing the bending moment diagram, we have to calculate the maximum bending moment. For AB and CD column, there is no load acting, therefore there is no maximum bending moment for particular portions. And for BC portion, there is UDL load acting. For UDL condition, formula is WL squared by 8. Substituting that, we will get maximum bending moment for BC portion is 45 kilonewton meter. Using the maximum bending moment and final moments value, we have to draw the bending moment diagram as shown in step 5. Second part of the problem, shear force calculation. Shear force calculation, we have to calculate the reactions first and then shear force diagram. Shear force calculation will be calculated for each span using the bending moment calculator in the step 4. For AB portion, there is no load acting as given in problem. We have to consider only the moment at left hand and right hand. In left hand, there is 12.03 clockwise direction and in right hand 23.89 clockwise direction. It is considered. Taking moment at B point, we will get RA into 3 meter and clockwise 2 moments, 12.03 and 23.89 in positive direction. Finally, we get RA value as minus 11.97 kilonewton. Summation V is equal to 0. We get RA plus RB1 is equal to 0. Substituting RA value, we will get RB1 as 11.97 kilonewton. Similarly, for BC portion, there is load acting 10 kilonewton per meter as UDL and both the end moments are calculated. Taking moment at C point, we will get RB2 into 6 meter minus 10 into 6 into 6 by 2 as for UDL portion and plus 23.89 and minus 23.89 as left and right moments equal to 0. Finally, we get RB2 as 30 kilonewton. Substituting that in below equation, we get RC1 as 30 kilonewton. Similarly, for CD portion, there is no load acting at the CD portion. We have to consider only the moments. Finally, we get RC2 and RD value as 11.97 kilonewton and minus 11.97 kilonewton respectively. Step 7. Using the above reactions value, we have to draw the bending moment diagram. Using above reactions, we have to draw the shear force diagram. Shear force diagram for AB portion. In A point, there is reaction minus 11.97 kilonewton. It is in negative direction. Therefore, it is drawn below the A point. And up to the B point, there is no load acting. Therefore, straight line drawn. In RB portion, reaction 11.97 acting minus 11.97 plus 11.97 is considered as 0 and connected in the B point. For BC portion, RB2 is considered as 30 kilonewton. It is in positive direction, therefore drawn upward. From B point, there is 10 kilonewton per meter load acting. Therefore, 10 into 6, 60. 30 minus 60, it is considered as minus 30. It is done inclined line because it is UDL load. Minus 30 from that point RC reaction 30 kilonewton already calculated. Adding both that value we get 0. For CD portion, RC2 is 11.97 in positive direction, therefore from C point it is drawn upward direction. From C to D there is no load acting, therefore it is drawn direct line. In RD there is reaction minus 11.97 kilonewton. Adding 11.91 and minus 11.97 we will get 0 as connecting point in D point.